All right, so the arithmetic topic is one of the most common topics that you're going to find in your GRE. When you'll be sitting for your GRE exam, this is the topic that you're going to find carries the most weight. This is going to be about 60% of your entire exam. So this topic is really, really important. Right, so arithmetic is usually like everything to do with mathematics, every single calculations you'll be doing from here going forward. All of it, we might be having different topics, but everything boils down to arithmetic. Arithmetic is the most basic and it's the most basic part of the GRE. This is what carries everything. So every addition, subtraction, multiplication is going to be in this topic. So I hope we take this topic with all the seriousness it deserves, because this is what is going to give you about 60% of your marks. Right. So I'm just going to get started here. The first part of, so we'd spoken about going through four subtopics rather within arithmetic, like what to expect within arithmetic, 4 subtopics. So it has about 8 subtopics total in it, but today, depending on our time, I'm going to try and teach you as much as possible in the part of the first 4 topics. So the first topic, and this is the basic of mathematics, will be the integers topic, right? So when you're talking about integers, is everything to do with real numbers, also everything to do with whole numbers. And then we have negative numbers and all that, and so on and so forth. So everything to do with numbers and subtraction and multiplication is all integers. That's why we are starting with this in this session. All right. So I know most of us know what this is, the order of operation. Are we given importance whenever you're given a question? How do you carry out like a subtraction, multiplication types of equation? I know most of us know PEMDAS. Some of us are used to what we call BODMAS. So we have PEDMAS and BODMAS. This is usually used in the UK, Australia, most Kenyan schools also. Most Kenyan schools, you might have used BODMAS when you're learning your mathematics in primary school and in high school. Depending on also where you've learned, you might have gone through PEDMAS. It's basically the same thing. The only difference usually like how you do your division and multiplication. This is PEMDAS, this is PEMDAS, right? So the GRE usually uses PEMDAS because it's a standardized test. If you use BODMAS, it's okay, but most of the time you'll find they will require you to use PEMDAS. So PEMDAS stands for P being parentheses. So we know what parentheses is, still brackets. So whatever is in the brackets, usually whatever will always come first. Whenever you're given a question and it has something in brackets, always ensure that this is the mathematics you carry out first, right? The equations that you do first will always be the ones that are inside the bracket. The next part is the exponents. Exponents are also called powers. We're going to be going through some of these. So whenever you have something squared, so if it's 2 squared, 2 squared minus 1, you'll always do this before doing this, right? So exponent is what is given the next priority. For BODMAS, this is, of course, is off. So if you're told a half of 22 plus 3, you're going to do this, and then you're going to do this, and then you're going to multiply. So half of 20 is 10, and then 5. So something like that. So off, you're not going, it's very rare for you to find like something called off in the GRE. So this is why you don't use BODMAS often. Off is not usually very common in the GRE. The next part you will be doing is the multiplication part, followed by the division, addition, and subtraction. I know most of us know this. So to help us just remember how this one used to go, I think we're going to have an example here. So we have this first example is what we are looking at here. What is the value of 5 times 2 power 3 minus 2 times 3 plus 1 squared? Right, so again, PEMDAS here. So 5 times 2 power 3 minus 2 times 3 plus 1 squared. So this one, we will solve whatever is in the bracket first. This will give you 4 squared times 2 minus 2 cubed times 5. So the next one will be, of course, be exponents. We need to do all our exponents. So this is 5 times 2 cubed is 16 minus 2 times 4 squared is again 16. The next part will be the multiplication. So you'll do 16 times 5, which is 0 carry 3, 80, minus 2 times 16, which is 32. This is going to give you 48, all right? So again, this is whatever you used to do in high school is what, just a second, allow me to allow people in. So the same thing that you used to do in high school is what you're going to do in the GRE. 2 cubed should be 8. Yeah, of course. Yeah, sorry about that. 2 cubed. 2 times 2 times 2. So this is supposed to be 8. So it's going to 40 minus 32 is equals to 8. Yeah, so thank you for that correction. I did not notice that. 2 cubed is equals to 8. So it's 5 times 8 minus 2 times 4 squared is 16. This should give you 40, minus this should give you 32, giving you a correct answer of 8. All right. So the same thing that you did in high school is what will apply to the GRE. There's nothing special about these types of question. The next example that we'll have, and I would like everyone to try this one out. I'll give you 2 minutes. Mitchell plans to work at a day camp over the summer. Each week, he will be paid according to the following schedule. At the end of the first week, he will receive $1. At the end of each subsequent week, he will receive $1 plus an additional amount equal to the sum of all the payments he received in the previous week. How much money will Mitchell be paid in total during the summer if he works for the entire duration of 8-week long camp? All right, so let me repeat that question. Mitchell plans to work at a day camp over the summer. Each week he will be paid according to the following schedule. So this is the schedule. At the end of the first week, he will receive $1. At the end of each subsequent week, meaning subsequent week again, meaning the weeks that follow after the first week, he will receive $1 plus an additional amount equal to the sum of all the payments he's received in the previous week. How much money will Mitchell be paid in total during the summer if he works the entire duration of the 8-week long camp? All right, let me give you a second, 2 minutes, try out this question. Let's see. Let me see your answers in the chat. What do you think is the answer here? How would you, if you are doing this one in your GRE exam, how would you do it? All right, let me see some answers in the chat. I'm going to give you 2 minutes, try and cover that. So this is the question we are covering here. I want to see some answers in the chat. What do you think? What do you think the answer is? What do you think the answer is? I want to see some of you try it out. Let me get at least 5 people, and then we can do it together and see what you would have done. Yeah, seeing something in the chat. All right, we have 36. We have Vincent saying 36, Margaret saying 36. Okay. Let me get 2 more people and then we can do it together. Faith 36, Daniel 36. Awesome. So let's do it together. So you're being told he's working the first week, he will receive $1. So this is week 1. Then at the end of each subsequent week, meaning from week 2, he will receive $1. So let's try out week 2 here. He will receive $1. So $1 plus an additional amount equal to the sum of all the payments he has received in the previous week. So here he received $1. And what did he receive in the previous week? That will be $1. So this is $2 here. So week 3 will be what? $1 plus all the previous week. What will be the previous week here? It will be 1 for week 1, and then plus 2 for week 2, and then week 4. So this is going to be what? 2 plus 1 is 3, plus 1 here gives you 4. Then week 4 is going to receive 1 plus all the previous weeks. So you have to check out the previous week. So week 2 he received 4, then week 3 he received 4, week 2 he received 2, and then week 1 he received 1. So this is 4 plus 2, 6 plus 1, 7, This is going to give you 7 here. You notice I'm always doing whatever is in the brackets first, and then plus 1 is equals 8. So week 5, 1 plus 8 plus 4 plus 2 plus 1. It's going to give you 8, 12, 13, 14, 15. So 15 plus 1, 16. So if you're a smart student, you'll be able to notice immediately we are doing the powers of 2. So if you're a smart student, you've already noticed we are doing the power of 2. So it's going to be 1, and then 2, 4. This is what? 4 plus 2. Let me confirm I'm doing this correctly. Yeah. So 4 plus 4 is 8. Then 8 plus 8 will be 16. So this is week 1, week 2, week 3, week 4, week 5. And then it's going to be 32, week 6. So this is going to be 16 plus 8 plus 4 plus 2 plus 1 plus the extra $1. So it's being 8, 9, 10, 11, 12, 13, 14, 15 plus 1, 16 plus 16, 32. So then week 7 is going to receive what? 32, and then it's going to receive 64, I believe. Me, I'm seeing some comments. No, it's additional for the previous weeks, not for the previous week, not all previous weeks. Sum of all the payments he received in the previous weeks, right? I typed this question wrong. Sum of all the payments he's received in the previous week. Right. In the previous, I was supposed to type previous weeks here. Sorry about that. But yeah, let's do it with the way it is right now. Apologies for that. I don't know why I'm making those silly mistakes. This is sometimes the issue. You need to be really careful when you're solving these types of questions. Yeah, I'm trying to admit people at the same time. I'm trying to read these questions. That's why I'm a little bit distracted. Apologies for that. All right, let's see here. All right, Mitchell plans to work each week. He will be paid according to the following. At the end of the first week, he'll receive $1. Then at the end of each subsequent week, he will receive. All right, let me just admit people. Sorry about this, everyone. People keep dropping out and coming back in. It's a little bit distracting. He will receive $1 plus an additional amount equal to the sum of all the payments he received in the previous week. So in week 2, he will receive $1 plus what he received in the previous week, which is $2. So $1 plus $1 plus what he received, are some of the payments he received in the previous week. So this one, when you're trying to solve this one, is what did he receive? What was he paid in the previous week that he was working? So this is 1 plus. So week 2 here is going to be paid $1 plus what he was paid in week 1, which is $1 plus he was paid $1 in week 1, which is $2. So week 3 here, he was paid $1 plus what he was paid in week 2. Week 2, he was paid $1 here. So it's going to be $3 here. So week 4, he was paid again $1 plus what he was paid in week 3. So he will receive this, what this means, plus an additional amount equal to the sum of all the payments he received in the previous week. So $1 plus what he received in the previous week. So again, $1 plus $3, so 4. So it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, right? So that comes up to, I believe it's 36. So it is 3, 6, 10, 15, 21, 28, 36. Yeah, that's 36. Thank you for that. So you notice how you always do that. So always make sure you work out. Always make sure you work out depending on the bracket. So if I was working on brackets here, this is going to be week 1 plus what you received 1 plus week 2. So this is just a basic example. This is probably like a 140 level question, not a very high level question. This is a very simple question that it's going to test your ability to be able to break down these long type of questions. All right, so I'm going to share this in the group so that we can be able to focus on these. For the next maybe 20 minutes, I'm not going to be admitting anyone to the class until we at least we're able to go through a few of these things. All right, so if someone tries to join, they're asking in the group why they're not being let in, please ask them to allow us 20 minutes so we can be able to focus on whatever they're learning here, because I've already given people about 30 minutes. So yeah, so let's go on. Sorry about that. So the next part, these are something that you need to learn when you're working with the GRE. So when working with conversions in the GRE, always try to get down to 1 unit. So this is very important for integers. Whenever you're given anything, always make sure you break down to 1 unit. So find what is the 1 unit for. If you're given a conversion from kgs to pounds here, always try to find like what's 1 kg to something like pounds. If you're given meters cubed to centimeters cubed, for example, always try and find what is like the 1 meter cubed equal to the centimeters cubed, if it's 1 million centimeters cubed or whatever it is. So it's always important when you're working with your GRE to always try and get down to the 1 unit, like find whatever is going to be the conversion for the 1 here, right? So I have an example here for us to work out so we can see what I'm talking about. So Cardi weighs 78 kilograms, which is 172 pounds to the nearest pound. So you're asked quantity A is 10 pounds, quantity B is 4.5 kilograms. What you can try to do is try and find like what's the 1 kg in pounds, or what is 1 pound in kg. So you're being told 78 kgs is approximately 172 pounds here. So 78 kgs is 172 pounds. What about 1 pound? We'll try and convert these. So if you're given quantity A, quantity B here, the options here will be A. Quantity A is greater. Then B. Quantity B is greater. C is the two quantities are equal. So quantities are equal. And then D is the relationship cannot be determined. Right. So this is usually like these will always be the options when you're seeing these are always the options when you're seeing these types of things. So whenever you have quantity A and quantity B, is always going to be answer. Your quantity A is greater, meaning this and this is equal. Quantity B is greater, meaning quantity B is greater than this. Then quantities are equal, meaning whatever you find in quantity A and quantity B is equal, and then the relationship cannot be determined. So let's try and solve this question here. You're told Cardi weighs 78 kilograms, which is 172 pounds to the nearest pound. You ask quantity A is 10 pounds, quantity B is 4.5 kilograms. What's the relationship between these two? Is quantity A greater? Is quantity B greater? Are these quantities equal? Or you cannot determine the relationship here. So this is why I was saying, whenever you have different, you see this is in kilograms and then this is always in pounds. Always try and convert that to the nearest 1 unit and make them similar. So here you can try and convert this to pounds or to kilograms, or you can try and convert the kilograms to pounds, whatever works for you. But always try and make sure they are equal and then to the nearest 1 unit here. So I'll try and convert the kilograms to pounds here. So 78 kilograms is equals to 172 pounds. What about 1 pound? It's going to give you 172. It's going to be divided by 78 here. You can do that very quickly in your calculator. Divided by 78. It's going to give you about 2 point, because 78 is about 78 plus 78 is usually about 156. So you know it's 2 point something. You don't actually have to get like the exact amount. It's 2 point something, 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 yeah? So the good thing about GRE for these types of quantity and quantity, you don't usually actually have to find like the exact decimal amount. So that it saves time whenever you are doing a division like this. I don't need to know the exact decimal point here. I just need to know that this 78 is going to go into 72, 2 point something. So it's just going to be 2 plus something. This is 72 pounds. So yeah, this I'm doing this 78 times 1. Let's do pounds in kilograms so we can find a whole number about 1 kilogram here. So this 100. Let me erase these here. We're trying to find the one that will give us a whole number so we can be able to do that division very quickly. So they're telling us 78 kilograms is equals to 172 pounds. So what about 1 kilogram is equals to what? Again, cross multiplication. So it's 1 kilogram times 172 pounds divided by 78 kilograms. So cancel this out. Then this is going to be 2 plus, so 2 plus something here. So 2 dot dot, that's something. So that's what the value of one pound is equals to 2 plus something kgs here, right? So let's convert these, whatever we have here, to I believe it's pounds. So let's see here. Let me just clear some space again. So of course, if you're able to solve this before me, always feel free to give us your answer in the chat there. I always like students who are helping out whenever they can. So if you're able to solve this before me, always, let's see. Answer C. Let's see. They're equal. All right, Margaret, where do you think they're equal? Margaret, Kenya.
Yes, boss, I used, for me, I've used, if 78 kgs is 172 lbs, what about 10 lbs? So that is 780 divided by 172, you get 4.5. Quantity B is 4.5, so they are equal.
But is it 4.5?
It's 4.5 something.
Is you see, is it 4.5?
Oh, it's 4.53.
Exactly. So does that make them equal?
Also, quantity A is bigger because of the 0.3.
Awesome. So I see you have noted something, right?
Yeah.
This is 4.5 plus something, right? And then this is 4.5, exactly 4.5. It does not have like another decimal places here, Cindy.
Yeah.
So these small multiplication, these small divisions, whenever you round off in the GRE, I was hoping you would note that, and it's So Shadrach, yes, that's correct. It is quantity A is greater because this is not 4.5. 10 pounds is not 4.5. It's 4.5 plus, meaning 4.5 point something. This is 4.5000. So this, even the small decimal points always bring a difference, especially in this question, right? Whenever you are comparing quantities, don't round off too early. Always carry your fractions always carry your decimals until you get to the end. What I like to do is, if I don't want to write 4.3, whatever it is, I always write this is 4.5 plus, meaning it has some things here. This is just 4.5 flat here. All right. So we have something similar in the second example here. You're being told 1 feet is equals to 12 inches, right? Area of 5 feet by 5 feet garden. Let's see. Are you going to make the same mistake? Are you going to round off again too early if there's rounding up? So that's 600 square inches. So this one we have 1 feet is equals to 5. 1 feet is equals to 5 inches. What about 12 inches, right? So it's going to be 60 by 60. It's going to give you 3600 square inches. And these, I believe someone said correctly that they're equal. Let me see. For the second question, Vincent. For the second question, what do you mean for the second question, Vincent? C. Yes. So for this option, for this second option here, this one, there's no like decimal point, there's no anything. It's clearly that 600 square inches. So this one is option C here, meaning the quantities are equal here. So always be careful in integers whenever you're doing, especially these questions for does the statement to the nearest pound matter in our analysis of question 1. So here, not necessarily, especially whenever you're what they're informing you here is let me see who's asked that question. Jacob Kitinya. It depends. All right, Jacob, it depends on how exactly it's been used. For example, here now, this to the nearest pounds, meaning they use this conversion here to get this one to the nearest pound. They're not telling us to do this to the nearest. They're not telling us to convert this to the nearest pound. They're telling you Caddy weighs 78 kilograms, which is 178 pounds to the nearest pound, meaning the information they're providing here, meaning they're already rounded it off for us. So it depends on how that statement is used in our what do we call, in our question rather. So if they are telling you what is maybe what is 1 kilogram to the nearest pound, for example, I would ask you to do it to the nearest whole number here. So do it to the nearest whole number. So the answer there is yes and no. It really depends on how it is used. This is just an example I picked somewhere. So, but the GR is usually very clear. All right, it's usually very clear. Who asked the question? Jacob. Yeah. So the GR usually tells you like how exactly it needs you to work out on that question. So if it tells you to the nearest pound, it's going to tell you to use that to answer your question. If it's telling you whatever was to the nearest pound is whatever was used in the question, it's going to be very clear about that. So you don't ever have to worry about like it being unclear. The GR will always be very clear in its question. All right, so in integers, it's always important for these questions where you have quantity A and quantity B. Jacob, that's a very good question, to always be very careful, especially with the decimals, with to the nearest pounds, to the nearest whole number, to the nearest decimal, right? How are you running off? So if you are told 4.55 to the nearest whole number, right, this will be 5. But if you are told 4.55 to the nearest, like 1 decimal point, 4.6. So it's going to be very clear to you what exactly it needs you to do.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
Another example we have here, the number of seconds in 12 hours, and then the number of minutes in 720 hours. So let's try this one out. The number of seconds in 12 hours, and then the number of minutes in 720 hours. What do we think the answer will be for this? What do we think the answer will be for this? The number of seconds in 12 hours, and then the number of minutes in 720 hours. How will you do it? Let me give you a minute. Let me see some options that some people have. Let's see at least two new people giving us an answer in the chat. They're equal. Faith is saying they're equal. Faith, why do you think they're equal? Equal, Richard, thank you. Faith, why do you think they're equal? Guide us through your process.
1 hour has 60 minutes and 60, so it will be 12 times 60 to get the seconds. And then quantity B, the number of minutes in 720 hours will be 720 times 60 as well. You get 43,200 for both.
So 43, you're telling me it's 43,200, and then 43,200 here. Anybody with a opposing answer? All right, I'm seeing equal. Nice. Yeah. So yeah, that's basically whatever Faith has explained. That's correct. So this is just the same. So if you decide to do 12 times 60 here, you can do 720 times 60 times 60 times 60. You can use your calculator. Equal. So you can use your calculator, or you can think about what is 72? 720 rather. 12 times 6 is what? 72, right? So this will be 12 times 60 times 60. Then this is 12 times 60 times 60. That's by their shortcut. You don't have like to get your calculator out to do like what 720 times 60. You don't have that time of typing it in the GRE. So you've gotten this is 720 times 60. This is 12 times 60 times 60. The GRE, again, another important point to note, when they give you these ones, they usually like there's something. There's usually a secret when they give you these types of question, quantity A and quantity B type of question. There's usually like a secret that they want you to figure out. So, for example, in a question like this, maybe for people who know 12 times 6 is 720. So this is 12 times 6, and then we have 1 0 here, then times 60. So very quickly, even without getting out your calculator, you'll be able to figure out that both of these quantities are equal, right? So I hope that's something you've been able to note. So the next, I think another example here, very quickly, 1 kilogram is equals to 2.2 pounds. So the number of kilograms in 44 pounds, and then the number of pounds in 44 kilograms. 1 minute for that. This is a very simple question. Number of kilograms in 44 pounds, and then number of pounds in 44 kilograms. Very simple, but also a little bit, you might get lost. Ian Toy is telling us B. Ian, talk us through your process. Well, how did you find that quantity B is greater?
Excuse boss, before we proceed.
Go ahead.
For the first question.
Who is this? Sorry, I can't see. Richard. Okay, Richard. Go ahead, Richard.
We are comparing the number, or because quantity A will be 43,200 seconds, quantity B will be 43,200 minutes.
Very good question. So whatever you're being told is to compare, is just compare whatever the answer that you'll find for quantity A and quantity B, not the units, unless they will tell you expressly again. But this one, you're just comparing the answer that you'll be able to get here. So what is the number of seconds in 12 hours? 43,200. The number of minutes in 720 is 43,200. Usually when they tell you to compare these two answers here, they don't usually, unless they tell you so expressly, they don't usually like care about the units after this. So if it's centimeter cube, this usually doesn't matter if it's meter cube. What they want is the number here.
Okay.
I hope that's clear, Richard.
Yeah.
Yeah, so for these questions where you have quantity A and quantity B, usually they care about the actual quantity, right? It's quantity. So they don't want to know about usually like whatever is following here, like it's second or minutes. Usually they're checking out these numbers. If they want to know, like if it's minutes and seconds and whatever, they wanted you to compare that, then they're going to tell you that directly. But usually they just need you to look at the quantity, unless they tell you differently.
Okay.
I hope that's clear.
Yeah.
All right. So Ianto, you have to explain to us like how you found quantity B is greater here. Sorry about that.
Okay, so in my thought process, you were looking at one kilogram is 22 pounds.
2.2 pounds.
2.2 pounds, yes. So if you're looking at the number of kilograms in 44 pounds, so that means I would have to divide the 44 pounds. Yes, so that will be give me a lesser quantity if I compare it to quantity B, because if I'm converting it to pounds, that means I have to multiply. So quantity B in my case, that's how I quickly got that answer. Not sure if I'm right or wrong, but I would go with B.
Okay. Anyone with a different opinion, or anyone thinks that's different? This is actually a very smart thing you've done there, Ian. So this is something I also wanted you to note when you're doing this exam. You don't always have to do like the long multiplication. Sometimes these questions just solve themselves. You've already been given this one as 1. So you don't need to do too much again here. What you just need to do is know how to do the cross multiplication that we usually do. So if 1 kilogram is equals to 2.2 pounds, what about 44 pounds here? Because multiply that will give you 44 divided by 2.2. Again here, 1 kilogram is equals to 2.2 pounds. Where you put in your quantity, what about 44 kilograms? So this is 44 times 2.2. And then even without doing that, you already know it's going to be greater because you're multiplying here and you're dividing here. So yeah, that's this gives you quantity B is bigger here. So Richard, you will see this one will give you something in it'll give you something in pounds, and then this one will give you something in kilograms. You might be tempted to say that because maybe if this one was bigger, you are checking this. So you don't usually check the units, Richard. So you just check the value that you've gotten here. So thank you for that. Yeah, but yeah, that's exactly how I would also solve that question. You don't have to do that long division. Once you've seen that this is just a division and this multiplication, you've already found your answer as quantity B. All right. Let's move on to what I think is the final example for this part. How many 1-inch square tiles would it take to cover the floor of a closet that has a dimension of 5 feet by 4 feet if 1 foot is equals to 12 inches? Let me see some of those answers there. How many 1-inch square tile would it take to cover the floor of a closet that has a dimension of 5 feet by 4 feet if 1 foot is equals to 12 inches? This one I would need an actual answer. So there's no quantity A and quantity B here. One more minute. All right, let me see. I see someone here has given us an answer. 2880, 2880. Let me pick Doug Njoroge is the first one to answer. Doug, how did you get to 2880?
Good evening.
Good evening.
Everyone. I got the dimension of one side, which is 5 foot. If 1 foot is 12 inches, that means that side is 5 times 12, which is 60. The other side is 4 times 12, which is 48. And since the tile is 1 by 1, it is going to be 60 times 48. So 2,880.
Awesome. I think that's the correct. I don't know what happened there. Let me try and share that again. So what you said is you check that one side is 5 feet and you've been told 1 foot is equals to 12 inches, right? So I'm hoping you did something like this. So it will give you 12 times 5 for one side and then times 12 times 4. Is this what you did? Giving you 60 times 48.
Yes.
So this will give you what?
2,880.
Awesome. Yeah. So that's it. That's the actual correct answer. So thank you for that, Doug. So yeah, usually again, and I guess I did not give you answer multiple choices here, but usually if you're able to get to this point here, you don't actually even have to do this multiplication most of the time. You will find, for example, in the answer here, you'll find answer A is going to be 2880, for example. Answer B is going to be something like 2432. Answer C is going to be something like 2321. Like something like that, right? So usually you just have to figure out, like, if I do 60 times 48 here, this one is going to give me like 0 at the end here. So because 0 times 48 is always the ones is going to be 0. So usually you'll find that most of the time the answer that has that final thing is usually like just one of them. So once you see like 0 times 48 is going to give you 0, you know that the ones is going to be a 0. So that will give you 2880. But yeah, that is the correct way of solving that. Thank you, Doug. Sharon, I'm seeing all your answers. Yeah, let's keep participating. Let's move to the next slide. So, how do you deal with big numbers when you're doing the integers part of the GRE? How do you deal with big numbers? So what is recommended is that you will always try and break it down to a power of 10. Whenever you're given a ridiculous number, always try and find what is the closest power of 10 that you can be able to get that answer to. and then solve that question without like ignoring the 10 power something part. Right, so to make that clear, let's do an example here. We have two examples. Number one, it takes light traveling from Earth 250 million minutes to reach Betelgeuse and 20,000 seconds to reach Pluto. Approximately how many times greater is the distance from this planet to Earth than the distance from Pluto to Earth? Again, a little bit of a thinker here. You have to be very careful how you're answering. Do you like do it directly? How do you answer this? I want to see some answers here. It takes light traveling from Earth 250 million planet to reach this planet and 20,000 seconds to reach Pluto. Approximately how many times greater is the distance of Betelgeuse to Earth than the distance of Pluto to Earth? Again, the wording of the question is very important. Right, so 1 minute, let me see people trying out, and then we're going to do that together. So again, break it down to a power of 10. Break it down to a power of 10. Once I see about 3 answers, 3 or 4 answers, we can do it together. One minute for all of us to do that. Mm-hmm. One minute. Mm-hmm. No answers, no trials. Shouldn't be taking you this long. This tells me people are doing some really long mathematics here. Tells me people are doing some really long. Let's see. This is 750,000 from Daniel Mutuku. Very nice. I need, let's say 2 more people and then we can continue. Margaret Kenya, 12,000. Interesting. 12,500 times. Shadrach, Vanessa have 12,500, and then we have Margaret giving us 12,000. Daniel Mutuku giving us 750,000. 12,500 from Shadrach and Vanessa. So, Daniel, let me confirm the name. So, Faith are giving us 750,000. The first person, Daniel Mutuku. How did you find 750,000? How did you come about 750,000?
Okay, for my case, I found out that it says that takes like traveling from other 250 billion minutes. So it is 250 million. Yeah, and then times 60, since it is you're comparing with 20,000 seconds. And then I did the calculation and I found 750,000.
Did you use a calculator?
Okay. The calculator, yes, I did use calculator.
Okay. That's understandable. That's understandable. So if I was the one that was doing this question, how would I take it? How would I do it? So we have light traveling from Earth from Earth takes 250 billion minutes. So 250 billion is what? 250 million. So 250 million would give me, I would say this is 25 times 10 power 7, because 250 million is 250, then 1, 2, 3, 1, 2, 3. So this is 1, 2, 3, 4, 5, 6, 7. right? So it's going to take 25 times 10 power 7 minutes to reach this planet called Betelgeuse, and 20,000 seconds to reach Pluto. So it's going to take 2 times 10 power 1, 2, 3, 4. 2 times 10 power 4 minutes, seconds to reach Pluto. Approximately how many times greater is the distance from Betelgeuse to Earth? So what they're basically asking you to do is find the distance from like how the distance is. So this one is 25 times 10 power 7 minutes. We need it to be equal. So as I said, when the only time the amount here, like seconds, minutes, meters cubed, is not required is when we are doing quantity A and quantity B. When we are doing these types of questions for quantity A and quantity B, these are whatever the STI unit here is not like required. But whenever you're doing these other questions that have options A through B, you're going to need to check out for these. But they have to be equal whenever you're doing this calculation. So the ST unit is not usually required if you are doing quantity A and quantity B, unless you're doing conversions. But for this one, you're going to need to do that. So let's find the distance from in seconds. So whenever we are calculating distance, we are talking about light speed here. So this one is going to be times 60 is what it takes. It takes the light to travel. So it's 225 basically times 10 power 7 times 60. So these seconds to reach Earth, and then it takes 20,000 seconds to reach Earth, which is 2 times 10 power 4. So what you just need to do is divide the big number. How many times greater here? So they want to find the greater. So just divide the big number, 25 times 6 times 10 power 8. How have I found that? 60 is 6 times 10, which is 10 power 1. So we have 25 times 10 power 1, and then we have 10 power 7. So 10 power 7 times 10 power 1 is 10 power 8, divided by 2 times 10 to the power 4. So this one is 10 power 8 divided by 10 power 4. It's like 100 million, and then divide by, it's like 100 million divided by 10,000 here. So this 4 is going to cancel out 4 here. So it's going to be 10 power 4 left here. And then by 2, 3, it's going to give you 75, which is 25 times 3 times 10 power 4. So basically 750,000. So whoever found 750,000, that was the correct option. But yeah, so whenever you're solving these types of questions, this is what I was trailing about here. Always try and break it down to the closest power of 10 you can get. Always try and remove the tens, like the zeros, and group them together. Then solve these like simple equations together. So now you see I was only doing here 25 times 6 over 2, which is a pretty simple mathematics. You don't have to overthink like everything here. So just remove the zeros and then work with these values and then add the zeros in later. All right. I hope that is clear, so that people can try using the same trick I've just used. Try and solve for the second. Faith, I see you've raised your hand. Please go ahead.
When you take what you've divided, 2 into 6 is 3, and then you've taken 4 into 8. Is it not 4 into 8 you get 2?
No, this is
10
8 times, Cindy. So this is 1, 2, 3, 4, 5, 6, 7. This is 100 million, Cindy. 10 power 8 is 100 million, and then you divide by 10 power 4 is 10, 4 zeros, Cindy. 1, 2, 3, 4. This is basically what means. It's 1 and then 8 zeros and then 1 and then 4 zeros. So just cancel out the zeros. 1, 2, 3 cancels out 1, 2, 3, and then 1 cancels out 1. So it's just going to give you these 4 zeros. 1, 2, 3, 4. There's 4 zeros that are left. So it's 10 power 4. Usually you just need whenever you're given, like when 2 powers, we are going to go through this. I know it might be a little bit confusing, but we're going to go through this and then just right now within this lesson. But when you're given 10 power 8 divided by 10 power 4, just need to subtract those powers that you've been given there. It's going to give you, that's whatever is going to be left, 10 power 4. If it was multiplied 10 power 8 and then multiplied by 10 power 4, you just do 10 power 8 plus 4. Exactly, yeah. So it's going to give you 10 power 12. This is basically what it means. Awesome. I hope that's clear. So let's try out question 2. Let's see if we're able to use that that trick I just showed you to solve that one also. So question 2 says The GDP, gross domestic product, was estimated at 94 trillion in December 2021, while the global population concurrently estimated at 7.9 billion. What is the approximate global GDP per capita, meaning per person? Right, let me give you a minute there. Let me see some answers. We're trying to move fast because we have a lot to cover and then not too much time. So just a minute and then. GDP was estimated at 94 trillion in December 2021. Then while the population was 7.9 billion, what is the approximate? Again, don't work with the zeros. Put the zeros aside, work with the real numbers that you have. What is the approximate? That's one again, another thing that you have. What's the approximate? Just a minute, 1 minute left. Seeing an option. I'm seeing 12,000 from Ian. Very nice trial. 1.2 from Amos. 11 point. This Vincent is correct, but not approximate. What's the approximate? I need the approximate. Approximate means to the nearest whole number. 11E3. Jacob copied from the calculator direct. 11, but I understand 11 times 10 power 3. That's understandable. Just a joke. Shadrach Okinyi, 11,899, 11,900. I'm seeing people are not seeing approximate. Margaret, 12,000. All right, so we're being asked for approximate. Usually in the GRE when they ask for approximate, but I know it's because I'm not giving you multiple choices here. If there are multiple choices, I know all of you would have gotten them. But usually when they ask for approximate, usually to the closest like whole number to the closest whole number. So here we have 94 trillion. Trillion is we know trillion is 12,000. Deborah, Margaret, nice. So 94 trillion. So trillion is what? 12 zeros. And then 7.9 billion. 7.9 is how many zeros? Billion is 9 zeros. So ignore these ones first. Let's work with 94 divided by 7.9. So this is the same as 940 divided by 79. This one is going to give you like 12 point something. So 12, and then now come and bring back your zeros. You have 10 over 12 times 10, 9. So 12 minus 9 gives you 3. So you have 3 zeros left. 1, 2, 3. So whoever gave us 12,000, that was the correct option. Usually, you would have, and everyone would have gotten it with given you multiple choices here. But yeah, approximate is usually like to the nearest whole number. So how have I been able to find 12 without calculating? I've been able to know 79 will go into 94 once, and then the remainder. And then it's going to go again 2 times here because 79 plus 79 is what? 148, and whatever is being left here is close to 150. So it's going to be 2. I don't need to know the decimal places, so it's going to be 12,000 approximately. So whoever got 12,000, you can clap for yourself. That was correct. I hope, though we've used this method, always when you're dealing with very big numbers, break it down. Always you do the zeros, the tens rather, do the tens like together, and then I'll do the other like whole numbers together so that you don't get confused with all those zeros, right? Always group them together and then do them like that. I hope that is clear. So the next part that we'll go through over very quickly, I know most of us know this, is divisibility tests. This is also very important, the GRE. Divisibility test is going to be tested in so many different ways. So we have the divisibility by 3 and 9. This is the first very important divisibility that they usually use to trick you with in the GRE. You need to know the divisibility. So if the digits of a number sum up to a multiple of 3, then the number is divisible by 3. If the digits of a number sum up to a multiple of 9, then the number is divisible by 9. What does this mean? So if you have been given, for example, let's do 81, right? So 81 here. Just do 8 plus 1. 9 is a multiple of 3. It's a multiple of 9. So that means basically this number is divisible by 3. If you have 270, 2 plus 7 plus 0 gives you 9. It's divisible, right? But if you have something like 271, you don't have to do that maths. 2 plus 7 plus 1 is 10. This is not divisible by 3, right? So I hope we remember this. If the digits of a number sum up, so just sum. If you want to find a divisibility by 3, just do the sum. and then see if that whatever you find as the answer of that sum is going to give you like a number that's divisible by 3, or also a number that's divisible by 9. So that's the divisibility by 3 and then divisibility by 9. The next part we have is the divisibility by 6. If a number is even and is divisible by 3, so if it's even and is divisible by 3, then the number is divisible by 6. So it has to be divisible by 2 and 3, basically. A number like 18. 18 is divisible by 2 and it's divisible by 3, so it means it's divisible by 6. We have a number like 27. 27 is divisible by 3, but is not divisible by 2. So this one is not divisible by 6. So it has to be both divisible by 2 and 3. I hope this is very clear for everyone. So if a number is even and is divisible by 3, then the number is divisible by 6. You might think this is very simple, but whenever it comes in a question, this really confuses people, especially in the GRE when you don't have time. So these are the types of things you just need to remember, you need to learn. Divisibility by 4. If the last 2 digits are divisible by 4, then the number is divisible by 4. So even if you have 10,876,000 and then something like 512. So if these last 2 numbers here, you don't care about these other numbers. As long as these last 2 numbers here are divisible, so this is 12 divisible by 4. This means this entire number is divisible by 4. So whenever you are given a very big number, you don't need to look at the entire number. Just look at the last 2 digits. Then if it's divisible by 4, then that entire number is divisible by 4. The last 2 digits are what is most important. I hope that is clear. The next divisibility is by 11. If the difference of the sum of alternating values are divisible by 11, then the number is divisible by 11. If the difference of the sum of alternating values is divisible by 11. So we have an example here. Example is 5,467,302 divisible by 66. This one is just need to know if it's divisible by 11, right? So if it's divisible by 11, then it's going to be divisible by 66 here. So you have 5, 4, 6, 7, 3, 0, 2. So what they mean by the sum of alternating values, come here, pick these, the alternating, this is alternating, this is alternating, you skip one, this is alternating. So 5 plus 6 plus 3 plus 2 minus, so the alternating is 4, 7, and 0. So 4 plus 7 plus 0. So solve the brackets first. 6, this is 11 plus 3, 11, 12, 13, 14, 15, 16. 16 minus. If I'm doing this correct, 5, 6, 3, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then we have 4. Yeah, down is made a mistake here. Very careful. 4, 3. 4. Trying to get these. 4, 10. So it's 5, 6. So this one, skip one goes with this one. Skip one goes with this one. Skip one goes with this one. Then this one, skip one goes with 7. Skip one goes with 0. So we would have 5 plus 6 plus 3 plus 2. This was correct. And then minus 4, and then 7, and then 0. So 6, 11. Yeah, so this is 5 plus 5, 16. Minus 7, 8, 9, 10, 11. 11, 16 minus 11 is 5. So I don't know if that is, I hope I'm doing that correctly. Please, you feel free to correct me if you think I made a mistake there, right? But yeah, that's basically how you handle divisibility by 11. Try and find the alternate, then whatever answer you find, if it's the alternating value, you do the addition. Then something to note, the first number, whatever you're alternating, the first, usually like the leftmost number is what you usually will come like on the left, meaning it's the one that's going to begin here. So you can't say 4 plus 7 and then minus these other ones. Whatever you start with first here is what you will do like that, and then minus whatever you find like from the second one. It's going to be at the under bracket. So usually have your bracket there and then minus have your bracket there. So whatever is first is there, and then the second one, write it there, then write a plus whatever is like third and fourth, so 6 and then 7. Yeah, so that's how you do divisibility by 11. I hope everyone is clear on that. I hope you remember that this sometimes can be a little bit tricky if you are not very careful on how you're doing it.